In this video, we'll be graphing linear and nonlinear inequality. So let's look at the problems that we have here. Now, in a subsequent video, I'll be looking at systems of linear and nonlinear inequalities. But for right now, these are just single. The first one's a linear inequality. The degree of x is 1, y is 1. Notice in the second one, we have an x squared, so that's a nonlinear one. Number 3 has x squared, y squared. Again, nonlinear. And of course 4 and 5 are, again, represent lines. One's a vertical line, the other one's horizontal. So basically, when we graph an inequality like this, we first look at the graph of the boundary. Okay, it could be a line, it could be a broken line or dashed line, it could be a circle, it could be a parabola, any kind of curve, and then basically you're going to shade a certain area that would represent the solution. The first one then is a linear inequality, so we're going to look at the boundary. So x plus y less than or equal to 6. Boundary would be x plus y equal to 6, which represents a line. So the first thing we do is we sketch the graph of the boundary. 2 points determine a line, so we just pick values for x and y. So I'm going to pick x to be 0. And you can see if x is 0, y would be 6. So I get the y-intercept. I'll pick x to be, or y to be 0 now. And x is also 6. So then I just plot these points. So we go 1, 2, 3, 4, 5, 6, 0, 6 for the y-intercept, and then 6, 0 for the x-intercept. So I'm just going to say 6 is about 6 units from the origin, it's about right there. And then I draw a line. Now, if it doesn't have, if this inequality has a less than here and equal, if it has the equals, that means the boundary is going to be solid. In this case, it'll be a solid line. If it didn't have that equals there, it would be a dashed or broken line. So in this case, then, I'm going to put a line, it's a solid line there. I'm going to insert it from the shapes. So there's the boundary. Okay. So there's several ways to decide. Now all you have to decide is what side are we going to shade. Are we going to shade above the line, or are we going to shade below this line? And there's a couple of ways to do it. You can look at the inequality, what direction it is, but probably the easiest way to do it, or the more conventional way, is to pick a test point. Pick any point that is not in the line. Okay, so you notice that it could be above the line, or it could be on this side. That might, okay, say. So you can see 0, 1, it's not in the line. 0, 2, it's not in the line. 1, 0, it's not in the line. So any of those points would work, or you can pick a point over here. So I'm going to say my test point here is going to be 0, 0. And that point is below the line. So basically you just go to the inequality and put a 0 where the x is, a 0 where the y is, and how does the inequality read? That would be 0 plus 0, so that's 0. Would be less than or equal to 6. And then you just decide, is that a true statement? If it is a true statement, then you shade everything on that side of the line. If it's a false statement, then you shade everything on the other side of the line. Well, 0 is less than or equal to 6. Now notice if I had this greater than or equal, then it would be 0 greater than or equal to 6. That would be false. So in that case, I shade the other side. But in this case, I get a true statement. So all you have to do is just shade. So I'm just going to indicate this way, below the line. So the line is included, and then this is in my solution, right there. That's solution, yes. Now the only difference, if I didn't have the equals there with the less than, the only thing you'd have here is this would be a broken line, okay, or dashed line, and that's your solution. Okay? So right now we're doing just single inequalities, linear or nonlinear, and then in the next video that I do on this topic, it'll be a system, graphing a system of linear or could be nonlinear inequalities. Let's go ahead and cancel this. That's the solution to that one. The second one, we look at the boundary. Okay, so just make it into an equal. Just ignore the less than or greater than, whatever it turns out to be, and make it into an equal. And you graph this. So it'll be x squared plus 2. And you should recognize that as a parabola. Y equal x squared is just a parabola with vertex at the origin, so it kind of goes like this. If I put a 2 there, it simply moves the vertex 2 units up. So instead of passing through 0, 0, it'll go like this. And if it's a positive coefficient in front of the x squared, it opens up like a U that way. If it has a negative in front, the graph opens the other way. So this one opens up. Going like that. So it's just a graph with vertex at 0, 2, opening up. Okay, that's the parabola. And then basically on this type of problem, you're either going to shade everything inside here, or everything outside. So again, you can pick any point that is not on the boundary. So don't pick 0, 2. We can pick 0, 0. Okay, we can pick 0, 3. That's inside here. Okay. So I go with the easiest one, and my test point here, I'm going to say is 0, 0. So test point for me in this one is going to be, I'm going to use 0, 0. But it's obviously not on the graph. So you want to pick a point that is not on the graph. And then all you got to do is replace the x by 0, replace the y by 0. So we get here, we get 0. Greater than, put a 0 there over the x, that'd be 0 squared is 0, and the 2 is 2. And then you decide whether that's a true statement. Okay? If it's a true statement, then you shade everything on this side where the test point is, so that would be over here outside the parabola. But it's a false statement. So you just do the opposite. So then you just say, okay, it's everything in here. And then you would shade all that, but I'm just making it easier here and say, okay, this would be my solution set. Everything within that, that's your solution. Let's clear this. Now, the next one, ignore the less than, make it into an equation to get the graph of the boundary. Equals to 4. So you should recognize this as a circle. X squared plus y squared is equal to 4. That's a circle with center at the origin. Okay, so center is at the origin, 0, 0. And the radius is 2. So 2 units this way. 2 units this way, 2 units this way, 2 units down here. And then this one does have the equals, so this boundary is going to be solid. If it didn't have that equals down here, everything's the same. You still do all of this. If it doesn't have the equals, it's a dashed or broken circle. With the equals, it's solid. So in this case, I simply draw it as a solid. And then you just pick a test point. You can pick a test point inside the circle or outside the circle. You can pick 0, 3, okay, or 3, 0. Again, I'm just going to pick the easiest one, 0, 0. So my test point, again, I'm going to pick to be. Yes, you want something that's either inside or outside the circle. So my test point will be 0, 0. And then you plug that into the original inequality, and if you get a true statement, then you shade everything inside the circle. If you get a false statement, you shade everything outside. So here I go 0 squared plus 0 squared, and that gives me 0 less than or equal to 4. That's a true statement. So I shade everything inside. I always just shade this. I'm just going to draw this and some lines in there and say that's my solution. So everything inside here would be shaded. That's it. Again, if it doesn't have the equals there, everything's the same except you have a broken circle or a dashed circle. Clear this. Next one. X less than -2. This one's pretty straightforward. Boundary would be x equal to -2. And no equals on it. This you should recognize as a vertical line that passes to the point -2, 0. And it's going to be a broken line because there's no equal. There you have it. And then I'm either going to shade everything to the right of this vertical line or everything to the left. You can also do the inequalities if you're careful. This is saying x less than -2. Okay, so where would the x values be that are less than -2? Well, -3 is less than -2, -4. So basically, you know it's going to be over here. But if you can still use a test point, and the reliable test point 0, 0 still works. It's to the right of the line, so over here. So let's plug it in there. Put 0 where the x is, 0 where the y is. There's no y, so you don't have to worry about it. Just put a 0 where the x is, and that would give me a statement of 0 is less than -2. And of course, 0 less than -2 is a false statement. So that means I shade everything over here to the left. So my solution set would be over here. Again, if this had an equals under the less than, the only difference is this would be a solid boundary. Now let's clear this. The next one, that y greater than or equal to 3. So ignore the greater than for now and just make it into a regular equation. Y equal to 3. And you should recognize that as a horizontal line passing through the point 0, 3. And because it has the equal, it's going to be a solid line. So we have that. So again, I'm either going to shade everything above the line, this line, everything below. Again, you can see y greater than 3. Okay, so y values greater than 3 are going to fall somewhere up here. So you can tell right away that it's going to be, you're going to shade above the line. But the test point 0, 0 works again. Or any other point that's not on the line. You can plug it into the original. So put a 0 where the x is, so 0 where the y is. There's no x, so you don't have to worry about it. Just put in 0 for y. And let's say 0 is greater than or equal to 3, which is false. So that tells me that all the points are going to, any value over here is going to give you a false statement. That's all you're going to do. Pick your test point, and if it gives you a true statement, shade everything on that side. If it gives you a false statement, you shade everything on the opposite side. So since this was false and the point is over here below the line, and I simply shade everything above. So I shade this way, you go shade it, so you shade it nice, okay, but basically this is your solution set. That's going to be it for this video. Again, later on I'll have one dealing with systems of linear or nonlinear inequalities. Thanks for watching, and we'll see you next time.